This lesson is on percent yield. So in chemistry, when we talk about yield, we can use it as a verb, and then it means produces or forms. Produces, yields, forms. And our arrow in a chemical equation, we can say that that is yields. In chemistry, when we use yield as a noun, as when we were talking about the yield of something, we are talking about the amount of a product that gets formed. So this is specifically amount of a product from a chemical reaction or process. Now, there are two different types of yields, the actual and the theoretical. We're going to start with the theoretical. This is what we have been calculating every time that we've used stoichiometry to calculate the amount of a product. We have been calculating the theoretical yield. This is the maximum amount of a product that can be obtained. From the amount of reactants that you have. Okay, it's the maximum amount. And this yield, this is calculated using stoichiometry. So in the combustion of wax lab that we did, when you calculated the grams of carbon dioxide that were formed from burning the tea light for an hour, you were calculating the theoretical yield. And when you calculated the grams of water vapor, you were counting the theoretical yield. So this is the number if you have a perfect. If you have a perfect reaction, that would be your yield. Okay, so then what is the actual yield? This is the amount of product that you really get, that you actually get. So this is the measured amount of product obtained. So in that combustion of wax lab, if we had actually been able to trap the carbon dioxide gas and then measure it, that would be the actual yield. So the actual yield, this is what you really get from the reaction. And our theoretical yield, this is what you could have gotten if everything was perfect, which it usually is not, because there is always that error that we get in any laboratory exercise. So this is what you could have gotten. And then our percent yield, this is just what we really got, divided by what we could have gotten times 100. So our percent yield is the actual yield divided by the theoretical yield times 100. So we could also look at that as the measured amount of product over the calculated. And for this calculation, remember, this is for a product, not a reactant. This is for the products. All right, so let's do a problem where we can see how we can use this. So we have 50.0 grams of nitrogen gas are reacted with hydrogen gas, and 48.5 grams of NH3, which is ammonia, are measured at the end of the reaction what is the percent yield of the NH3? Okay, so this number right here, this is your actual yield. What you really got, what you measured after the reaction happened. So we're going to use our formula to get the percent yield. We need the actual divided by the theoretical times 100. We have the actual, we have to figure out the theoretical, and we're going to do that using stoichiometry. So of course, we need a balanced chemical equation that describes the reaction. So our reactants are nitrogen gas, nitrogen Hofbrinkel, so of course we have to write that as N2. Reacted with hydrogen gas, hydrogen also a Hofbrinkel, so we have to write that as H2. And our product is ammonia, which is NH3. So this is a synthesis reaction for ammonia. And then we have to balance. So we're going to need, let's see, we're going to need 2 of these, and then we'll need 3 of these. So there's our balanced chemical equation. Now, our problem tells us that we have 50.0 grams of nitrogen. This 48.5, we are not going to put that right here because we are saving this for stoichiometry. This is the actual. We want to figure out our theoretical yield. This is what we want to figure out. How many grams does the stoichiometry tell us we're going to get? Okay, so we just do dimensional analysis like we have been doing. So X grams of NH3, set that equal to the quantity that we do know, 50.0 grams of N2, multiplication sign and crossbar. We have grams, we need to change them to moles. So 1 mole of N2, and we have to figure out the grams of N2. So we need to do a molar mass. I'll just do that over here. So we have nitrogen, we have 2 of them. Look at the periodic table, 14.01, our molar mass is 28.02 grams in 1 mole. Grams of N2 cancel, multiplication sign and crossbar. Now we use the coefficients to do a mole ratio, and we see we have 2 moles of NH3 for every 1 mole of N2. Cancel out the moles of N2. We need grams, we have moles, so we need another conversion factor. And now we need to figure out the grams of NH3 in 1 mole of NH3. So it's molar mass, mole ratio, molar mass. So NH3, nitrogen, we have 1, H, we have 3, nitrogen 14.01, hydrogen 1.008. Let's do that calculation. 14.01 plus 3 times 1.008 equals 17.03. We take it to 2 decimal places. So that goes here, 17.03 grams of NH3. Okay, moles cancel moles. We have the unit that we want, grams of NH3. Check our sig figs, 3, 4, unlimited, 4. So our answer gets 3 sig figs. All right, 50 divided by 28.02 times 2 times 17.03 equals. So with 3 sig figs, we get 60.8 grams of NH3. This is the amount we would get if this reaction was perfect. But we didn't get that much. We only got 48.5. And there's a lot of reasons that can happen. Maybe some gases escaped. Sometimes you get byproducts. Lots of things contribute to the error. All right, so now we're going to do our percent yield calculation. So this is the grams of the NH3 that we actually got. So 48.5 grams. And this is of our product divided by our theoretical yield, the grams that we would get if everything was perfect, 60.8 grams of NH3 times 100. Okay, so let's see what we get. 48.5 divided by 60.8 times 100, and 3 sig figs. This has unlimited, that's not a measurement. So 3 sig figs, we get 79.8% for our percent yield. Okay, so this 50, you would never use that in the percent yield calculation because nitrogen is a reactant. So our stoichiometry, what we calculate, is always going to go in the denominator. All right, let's look at another type of problem that you might see. Okay, here, in another ammonia synthesis, the percent yield is 65.7%. How many grams of NH3 are actually produced when 100.0 grams of hydrogen is reacted with nitrogen? All right, so here we're given our percent yield and we need to figure out what we really got. So we need to go to our equation, of course. So that was N2 plus 3H2 yields 2NH3. So now we have 100.0 grams of hydrogen. And we need to get our theoretical yield before we can do our percent yield calculation. So we're going to look for the grams of ammonia that we get if everything was perfect and every little bit of those 100 grams of hydrogen went into making the ammonia. Okay, dimensional analysis. X grams NH3 equals 100.0 grams of H2. We need our molar mass calculation to get rid of the grams. 1 mole of H2. All right, H2, we have 2 atoms of hydrogen. So we need to add them up. So 2 times 1.008 equals, and since that has 4 sig figs, I'm going to take this all the way to 2.016. So 2.016 grams of H2 in 1 mole of H2. Grams of H2 cancel. Now we do the mole ratio from the coefficients. 2 moles of NH3 for every 3 moles of H2. Moles of H2 cancel. We need one more multiplication and crossbar. And now we need the molar mass of NH3, which we already calculated. So that was 17.03 grams of NH3 are in 1 mole of NH3. Moles of NH3, cancel moles of NH3. We have everything canceled. Our units are grams of NH3. Okay, let's see what we get. So 100 divided by 2.016 times 2 divided by 3 times 17.03 equals. And let's see, 4 sig figs, unlimited 4, so I'm going to go with 4 sig figs. So we get 563.2 grams of NH3. So remember, this is our theoretical yield. The yield calculated from stoichiometry, what you would get if everything was perfect. All right, so now we're going to use our percent yield formula. So our percent yield is, we know it's the actual over the theoretical times 100 for the product. So we're given our percent yield this time. So we have 65.7 equals our actual yield. This is what we're looking for. This is our X. X grams. We don't know what our actual yield was. Our theoretical yield, we just calculated that. Remember, this always goes in the denominator. So we have 563.2 grams times 100. All right, so now what we need to do is get x by itself. So we divide this side by 100. That means we have to divide this side by 100. We have to get this out of the denominator, so we multiply this side by 563.2. Multiply this side by 563.2. That cancels that. So now x is by itself. And we'll do that math. So 563.2 times 65.7 divided by 100 equals. So let's see, 4 sig figs, 3 sig figs unlimited, so this can only have 3 sig figs. So our answer then, our x, is 370 grams of NH3. So this is what we really got. This is what we would have got if it was perfect, and then our percent yield of 65.7. So they're the two types of problems that you will see with percent yield. That's all.